Chapter 8. Hazard Analysis and Preventive Controls Determination for Human Food. Following the preliminary steps, the next step in developing a food safety plan is to identify the food safety hazards requiring a preventive control. This depends on the food, the ingredients, the equipment, the facility layout, and other elements of the facility's food safety system. Once the hazards requiring a preventive control are known, preventive controls can be identified to help ensure the safety of the product. Keep in mind that while many different types of controls may be applied when processing a food, preventive controls are risk-based and focus on the hazards that present the greatest risk to food safety. It is important to identify these hazards first to allow resources to focus on the preventive controls that are essential to reduce food safety risks. Let's take a look at some very important definitions. Hazard: any biological, chemical, including radiological, or physical agent that has the potential to cause illness or injury. Known or reasonably foreseeable hazard: a biological, chemical, including radiological, or physical hazard that is known to be, or has the potential to be, associated with the facility or the food. Hazard requiring a preventive control: a known or reasonably foreseeable hazard for which a person knowledgeable about the safe manufacturing, processing, packing, or holding of food would, based on the outcome of a hazard analysis, which includes an assessment of the severity of the illness or injury if the hazard were to occur and the probability that the hazard will occur in the absence of preventive controls, establish one or more preventive controls to significantly minimize or prevent the hazard in a food and components to manage those controls, such as monitoring, corrections or corrective actions, verification, and records, as appropriate to the food, the facility, and the nature of the preventive control and its role in the facility's food safety system. Preventive controls: those risk-based, reasonably appropriate procedures, practices, and processes that a person knowledgeable about the safe manufacturing, processing, packing, or holding of food would employ to significantly minimize or prevent the hazards identified under the hazard analysis that are consistent with the current scientific understanding of safe food manufacturing, processing, packing, or holding at the time of the analysis. These definitions are important to understand as we move into the lecture covering hazard analysis. Conducting a complete and accurate hazard analysis is one of the most difficult but important steps in developing an effective, risk-based food safety plan. Systematic and thorough analysis of potential hazards and their consequences helps to ensure that all hazards requiring a preventive control are identified. Occasionally, the thorough hazard analysis may identify a situation where a newly identified hazard exists and is not being adequately controlled. For example, several years ago scientists demonstrated that E. coli O157H7 tolerated higher levels of acid than other pathogens. Reviewing the hazard analysis for some fermented products suggested that formula or process adjustments were required to ensure that E. coli O157H7 was destroyed. A proper hazard analysis can also focus limited resources on the most important controls. Improper hazard analysis can result in an ineffective food safety plan if a hazard that must be controlled is overlooked. Conversely, an improper hazard analysis may identify too many controls for hazards that are not reasonably likely to cause illness or injury, which results in a system that cannot be effectively managed by available resources. For this course, hazard analysis is defined in the slide. The purpose of the hazard analysis is to develop a list of potential food safety hazards and then determine the hazards requiring a preventive control because they are reasonably likely to cause injury or illness in the absence of control. Once these hazards are identified, then preventive controls that are essential to prevent illness or injury can be determined. Only those hazards that pose a risk to the health of consumers should be included in the food safety plan. Not all potential hazards require a preventive control in an individual operation. A sequence of steps is followed to complete a hazard analysis, and each of the items listed above is discussed in this chapter. The hazard analysis process is based on the information organized in the preliminary steps discussed in Chapter 6, preliminary steps in developing a food safety plan, such as the ingredients and raw materials, activities at each process step, product storage and distribution, and final preparation and use by the consumer. Essentially, the information provided through the preliminary steps is a roadmap for conducting the hazard analysis. A hazard analysis form can be used to ensure that all steps are analyzed and the results are documented. The form also lists the hazards requiring a preventive control and identifies the type of control to be applied. Other formats, including formats that are not form-based, e.g., a written narrative, may be used as long as the hazard analysis is documented and contains the elements of hazard identification, hazard evaluation, and preventive control selection. A justification for decisions should be provided so others can understand the basis for the decisions. In this course, Column 1 is used to list each of the process steps from the flow diagram, including the receiving of each raw material or ingredient used in the process. Some may be grouped. Column 2, Hazard Identification, is used to list all raw material, ingredient, process, and environment-related hazards identified for each step. The hazards to consider are discussed below. Column 3 is a simple yes or no that states whether the hazard requires a preventive control. Column 4, Hazard Evaluation, is used to justify your answers. In Column 3, and sometimes in Column 2 if no hazard was identified but the team had a lot of discussion about it. Column 5 is used only when there is a yes in Column 3 to identify the preventive controls that significantly minimize or prevent the hazard, e.g., process, allergen, sanitation, supply chain, or other preventive controls. Column 6 is used to document if the preventive control will be managed at that step. Keep in mind that other formats may be used. The slide above represents 2 additional formats and others may be used as well. Model plans posted on the FSPCA website illustrate additional formats. Make sure that the format that you use is understood by your team in your facility and that it addresses allergen, sanitation, supply chain, and other preventive controls as applicable to the facility and food. We will use the E.g. Food Company omelet example to illustrate the hazard analysis process and complete a hazard analysis form. Set up the hazard analysis form by entering the firm's name and address, the name of the product or product numbers, the date the analysis is completed, and if it is a revision of a previous analysis, the previous date to keep records organized. A separate worksheet may be needed for each product type, but grouping products may be done if the hazards and controls are the same or if any differences are clearly delineated. We have grouped all of E.g. Food Company's omelets in this hazard analysis. A process flowchart was developed as part of the preliminary steps. This was discussed in Chapter 6. List each of the process steps in column 1 of the hazard analysis worksheet. This is the framework that guides development of this hazard analysis. One of the first steps from the flow diagram is illustrated in the slide. Remember, the full hazard analysis is in Appendix 3, Food Safety Plan example, as well in the chapter Resources. We will use the E.g. Food Company omelet example to illustrate the hazard analysis process and complete a hazard analysis form. Set up the hazard analysis form by entering the firm's name and address, the name of the product or product numbers, the date the analysis is completed, and if it is a revision of a previous analysis, the previous date to keep records organized. A separate worksheet may be needed for each product type, but grouping products may be done if the hazards and controls are the same or if any differences are clearly delineated. We have grouped all of E.g. Food Company's omelets in this hazard analysis. A process flowchart was developed as part of the preliminary steps. This was discussed in Chapter 6. List each of the process steps in column 1 of the hazard analysis worksheet. This is the framework that guides development of this hazard analysis. One of the first steps from the flow diagram is illustrated in the slide. Remember, the full hazard analysis is in Appendix 3, Food Safety Plan example, as well in the chapter Resources. Following identification of hazards, the food safety team decides which of the potential hazards identified present a risk to consumers such that it requires preventive controls. This includes consideration of the severity of the illness or injury and likelihood of occurrence. Columns 3 and 4 are considered at the same time on this form. Some organizations may add additional columns to capture separate discussion on severity and likelihood. Many factors should be considered when hazards are identified. For example, formulation of the food may result in pH, water activity, or other conditions that favor growth of certain pathogens and prevent growth of others, discussed in detail in Chapter 4. The condition, function, and design of the facility and equipment may enhance the potential for contaminants to be introduced. Some types of equipment may be more difficult to clean than others or more prone to wear or damage, e.g., metal fragments, which could result in an increased risk of hazards being introduced into the product. Ingredients and raw materials from your suppliers may introduce hazards, such as food allergens or pathogens known to be associated with specific types of foods. Water and ice as ingredients, and compressed air used in the food, e.g., for overrun in ice cream, could be considered here or could be considered at the process steps in which they are used. Transportation practices may influence the potential presence of pathogens. Bulk transportation may be more prone to potential contamination than packaged product transport. Ingredients that are transported under refrigeration may be subject to temperature abuse that could increase the risk of growth of certain hazards. Frozen transport may reduce risk. Processing procedures like cooking may reduce some hazards, e.g., vegetative pathogens. Other processing procedures may increase the potential for some hazards, e.g., metal chopper blades contacting hard materials may break and potentially contribute metal hazards. Packaging and labeling can influence hazards of concern. Labeling of allergens or the need for special storage conditions, e.g., keep refrigerated, may help to reduce the risk to consumers. Also, reduced oxygen packaging may increase shelf life but may also create an environment that supports the growth of C. botulinum or L. monocytogenes for some food. The potential for these hazards must be considered for reduced oxygen packaging. Storage and distribution conditions may suggest preventive controls are needed if pathogen growth is a potential problem. However, this may not be a food safety concern if products are shelf-stable. Consideration should also be given to the potential for the food to be contaminated in shipment, e.g., bulk cargoes. Some products are intended to be cooked or further treated prior to consumption, which may reduce risk for the consumer. However, it is prudent to consider how the end user may use the products in other ways, i.e., foreseeable use. For example, raw cookie dough is intended to be cooked prior to consumption. However, products such as cookie dough ice cream have been marketed as a ready-to-eat product. The formulation and processes for ready-to-eat dough must be carefully considered to avoid potential food safety issues because traditional cookie dough may use raw eggs, uncooked flour, and other ingredients that may contain pathogens. In addition, it is well known that some consumers eat raw cookie dough. The sanitary conditions of the equipment, environment, and employee hygiene are also a consideration for recontamination of certain products. Do the same employees handle both raw and cooked product? Do ready-to-eat product lines come in close proximity to raw product lines? How often do surfaces need to be cleaned to avoid growth in the system? All of these questions and more may influence the risk of creating hazards for certain products. Other relevant factors may include ingredient categories that have been implicated in food safety issues related to intentional product adulteration for economic gain, e.g., addition of lead-containing dyes to certain spices to enhance color. See the section on economically motivated hazards in Chapter 5, Chemical, Physical, and Economically Motivated Hazards. The severity of a food safety hazard depends on a number of factors that may include how long an individual is sick, whether symptoms are mild or severe, e.g., whether hospitalization or death is common, whether there is full recovery or health issues persist for long periods of time, and whether the food's targeted consumer is a member of a vulnerable population such as infants, children, the elderly, or the immunocompromised as discussed in Chapter 6, Preliminary Steps in Developing a Food Safety Plan. The severity of different hazards is discussed in Chapter 4, Biological Food Safety Hazards, Chapter 5, Chemical, Physical, and Economically Motivated Food Safety Hazards, and in more detail in Appendix 4, Foodborne Pathogen Supplementary Information. Some facilities may have the expertise necessary to make such evaluations. Others may need to seek outside assistance to complete this step. The bottom line is that when the hazard, if present, is reasonably likely to render the food injurious to health, it should be included. Appendix 4, Foodborne Pathogen Supplementary Information provides information on severity of common foodborne pathogens. Consider external assistance if you do not have the technical expertise to evaluate the severity of food safety hazards. It's attached in the chapter resources. The other factor the food safety team must evaluate is the likelihood of occurrence of the foodborne hazard. It is important to know how frequently the potential hazard may occur to determine if a preventive control is needed. In addition to food safety reference books, sources of data and information to consider include past outbreaks, recalls, the scientific literature, and establishment experience. Regulatory guidance, trade association information, and university extension documents also provide useful information on the likely occurrence of hazards in particular foods. Chapter 7, Resources for Food Safety Plans discussed many sources of information for identifying and evaluating food safety hazards. Past outbreaks present a tremendous source of information regarding the hazards that are likely to occur in certain food products. The food safety team should take into account lessons learned from these prior events and similar products. The notion that it has never happened to us should not be a reason for excluding a hazard if similar products have had an issue with a specific hazard. FDA provides information for the foods that FDA regulates on their findings related to outbreaks, frequently discussing the factors that contributed to the outbreak at a processing or production facility. The CDC has a wealth of information on outbreaks that occurred not only from processed foods, but also foods prepared in restaurants, retail establishments, and other locations. The CDC information covers not only FDA-regulated products, but also products regulated by USDA, e.g., meat and poultry, and those regulated by state and local agencies. Outbreaks that occur in other countries may also be relevant to consider, especially for imported foods. Food recalls are a useful source of information on the potential presence of hazards in specific food products. It is important to note that not all recalls are associated with foodborne illness outbreaks. Class 1 recalls involve products that are likely to cause serious adverse health consequences or death. Class 2 recalls involve products that may cause illness or injury, but the probability of serious health consequences is remote, and Class 3 recalls involve products that are not likely to cause illness or injury. Federal and state government websites post information on food recalls. It may be useful to investigate information on these websites to see if the product you are making has been involved in recalls. A standard reference book can provide basic information on food safety hazards. Peer-reviewed scientific journal articles and other sources of technical literature contain a wealth of information on foodborne hazards, their occurrence, potential growth in foods, and the case of biological hazards, and their control. A useful search tool is Google Scholar, which may be used to find the specific papers of interest. Microbial modeling programs such as the USDA Pathogen Modeling Program or COMBASE are available online and can be used to explore the potential for growth under a variety of conditions. Keep in mind that these models may not reflect exactly what will occur in a particular food, but they can indicate relative risk of different handling scenarios. The Codex Alimentarius Commission maintains internationally recognized codes of practice that are based on scientific literature and available in several languages. Trade associations also provide recommendations targeted to specific types of foods and industry needs. The establishment may have information on the likelihood of occurrence of hazards in their food products. This information can be gleaned from previous laboratory tests on finished products, ingredients, in-process materials, or environmental monitoring samples. Consumer complaint records can be a useful source of information, particularly for physical hazards. Various factors can influence the likely presence of food safety hazards, including effectiveness of plant operational programs such as receiving, storage and personal hygiene, frequency of association of the potential hazard with the food or ingredient, method of preparation, conditions during transportation, expected storage conditions, likely preparation steps before consumption. Hazards requiring a preventive control in one operation or facility may not require one in another producing the same or a similar product. For example, the probability of metal contamination may be high in one facility but not in another due to differences in equipment. The effectiveness of a preventive maintenance program can also be relevant in determining the likelihood that a metal hazard may be present. For example, Facility A may have a comprehensive preventive maintenance program that routinely inspects and tightens equipment nuts and bolts to prevent them from falling into product. They may couple this program with a review process for equipment designed to avoid installation of equipment with abrasive metal-on-metal contact. They may be able to determine that their prerequisite preventive maintenance program effectively manages the hazard of metal in the product because of their history of not finding missing bolts and lack of observing worn metal in equipment. Conversely, Facility B may not have such programs. It may occasionally find missing nuts that could have fallen into the product stream, and metal-on-metal contact may occur on some equipment. They may include metal detection in their food safety plan to investigate findings when kickouts occur. Both approaches are reasonable. Another example may be a facility that does not pack in glass containers, prohibits glass in the facility including instrument gauges with glass faces and watches, even for visitors, in the production area, and uses shields on light fixtures to prevent breakage. They may determine that glass does not require a preventive control. Conversely, a facility that does not have the resources to manage such a program or that packs in glass may conclude that the hazard presented by glass requires implementation of preventive controls. In the example, vegetative pathogens such as Salmonella is identified as a potential hazard in egg ingredients because of the history of outbreaks associated with egg products. Egg is also identified as a potential allergen hazard because egg can cause an allergic reaction in some consumers. Column 3 is marked yes, indicating that a preventive control is required, and Column 4 provides a justification of the decision. No additional information is needed for physical hazards because no potential hazards were identified. The facility could enter information in the justification field if desired, such as a comment that they switched from metal containers to bag-in-box to remove metal concerns. Hazards requiring a preventive control based on a hazard analysis for their severity and likelihood of occurrence must be addressed in the food safety plan. The term preventive controls is defined in the Preventive Controls for Human Food Regulation as indicated above. Note that the determination of a preventive control is risk-based, must be reasonably appropriate and consistent with the current scientific understanding. Keep in mind that the specific preventive control management components, e.g., monitoring, corrective actions, and verification, required takes into account the nature of the preventive control and its role in the facility's food safety system. For each yes in column 3, preventive controls that significantly minimize or prevent the hazard must be described. Column 5. If no known or reasonably foreseeable hazard is identified, column 2 for physical hazards above, or if column 3 is answered no, then columns 5 and 6 are left blank. Depending on the hazards identified, preventive controls may include some or all of the preventive controls listed on this slide. Specific types of preventive controls are discussed in chapters later in the course, but a brief description follows. Preventive controls identified at specific processing steps are process preventive controls, such as critical control points, CCPs, see Chapter 9. Process preventive controls. Allergen preventive controls, see Chapter 10. Food allergen preventive controls, include the essential allergen management procedures identified in the hazard analysis. Similarly, sanitation preventive controls are those specific sanitation procedures used to control the hazards identified as requiring sanitation preventive controls in the hazard analysis, and may include preventing contamination of ready-to-eat foods that do not receive a final preventive control measures or preventing biological, cross-contact, chemical, including radiological, sanitation and physical food safety hazards are listed in the slide above. Supply chain program preventive controls. For biological hazards, 12, common control measures program include those that either directly kill the manufacturer relies on the supplier to control a hazard requiring a preventive control in an ingredient because the receiving facility does not have a step to control the growth of microbial vegetative cell plan is not used to manage hazards requiring a preventive acidification. It can reduce the number of illnesses and a variety of time and temperature controls such as cooling. Other preventive controls and limiting time at temperatures that support growth. Sensitive operations. Supply chain programs. The term sensitive ingredient refers to an ingredient used in a history of association with a pathogen when controls are not in place. Controls may also be relevant for ready-to-eat products that are exposed to the environment. Preventive controls for chemical hazards include supply chain programs such as testing and rejection of ingredients that contain excess concentrations of natural or artificial chemical hazards. Allergen labeling is another allergen preventive control. Prevention of allergen cross-contact through sanitation may be considered an allergen or sanitation preventive control, or both. Physical hazards can be controlled by methods such as using equipment for straining or aspirating, mechanical separation, metal detection, or X-ray or other detection methods. These may be process preventive controls. Preventive controls for hazards introduced because of economically motivated adulteration may require a supply chain program or some of the methods above, depending on the specific hazard. The food safety team must consider many factors when identifying preventive controls for the food safety hazards requiring them. Selection of preventive controls should also include assessments with regard to its effect on identified food safety hazards, its feasibility for monitoring, its place in the system relative to other control measures, significant processing variability or the likelihood of failure of a control measure, the severity of consequences in case of a failure, whether the control measure is specifically established and applied to eliminate or significantly reduce the level of hazards, and synergistic effects between control measures. The example above illustrates the hazard analysis decisions for one step in the e.g. food company's food safety plan. Process control at a subsequent step, cooking, was identified as the preventive control for salmonella in eggs. Since the eggs are pasteurized, the company could have chosen a supply chain program instead. However, they may have concluded that it was easier for them to manage the cook step than a supply chain program. The decision is theirs in this situation. An allergen preventive control to ensure appropriate labeling was also identified as a preventive control. Preventive controls for both of these hazards, salmonella and the egg allergen concern, are applied later in the production process in this example. The food safety team, with the assistance of outside experts if necessary, must determine the specific preventive controls needed to control the hazards requiring them. As previously mentioned, other formats for the hazard analysis may be used as long as the essential controls for hazards requiring a preventive control are documented and implemented. More than one hazard requiring a preventive control may be addressed by a specific preventive control measure, e.g., a cook step may address both Salmonella and E. coli O157H7 hazards. For those familiar with HACCP food safety systems, keep in mind that not all preventive controls are CCPs. The actions that are taken for other preventive controls may be different from those required for CCPs. This is discussed in chapters 9 through 12 on specific preventive controls. At the completion of the hazard analysis, the food safety team documents the results of the hazard analysis process. A review of what is documented in the different columns for the model form used in this course is presented above. Other formats may be used, as long as they clearly identify the potential hazards, evaluate the likelihood and severity of the risk, and identify preventive control measures that are used for all hazards that are reasonably likely to cause illness or injury in the absence of a preventive control. Hazards requiring a preventive control must be managed through use of process preventive controls, allergen preventive controls, sanitation preventive controls, supply chain programs, or other preventive controls as appropriate for the food and facility. Operations or equipment in a facility may need to be modified based on the findings of a thorough hazard analysis. If the hazard analysis determines that a known or reasonably foreseeable, i.e., potential, hazard is likely to be present without a preventive control measure, then the product formulation, processing steps, other plant operations, or supply chain programs must be modified to ensure control of the hazard. Alternatively, there is provision for the preventive control to be applied later in the distribution of product. This is discussed in preventive controls chapters. The E.G. Food Company's plain omelet hazard analysis in Appendix 3 is an example of how a hazard analysis could be documented. In our example form, the step from the flow diagram is recorded in Column 1. In Column 2, potential hazards that may be introduced or increase at this step are identified. It is possible that a potential hazard is not a hazard requiring a preventive control. The decision is recorded in Column 3. Recording the rationale for the decisions made regarding hazards and preventive controls is useful to explain to others how the decision was reached. This is done in column 4. For hazards requiring a preventive control, a yes in column 3, the preventive control that needs to be implemented is identified in column 5. Column 6 identifies if the preventive control occurs at this step. It may occur later in the process, and that step would be marked as a preventive control. I'm going to give you about 20 seconds for each of the following slides that cover EG Foods hazard analysis. Take some time now to do a review, but remember the full analysis is also attached in the chapter resources. Please continue to review. 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 The full hazard analysis for the fictitious EG Food Company's omelets is in Appendix 3, Food Safety Plan Example. This appendix also includes a description of the process at each step to help visualize how this operation functions. A common hazard analysis may be used for a group of products that are similar in formulation, have similar processing steps, and are otherwise prepared and packaged in a similar manner. For example, the hazard analysis and food safety plan for the EG Food Company groups 3 different omelets into one hazard analysis and one food safety plan. It is important to note, however, that different formulations can have a dramatic impact on product characteristics, e.g., pH, different allergens, and these factors must be carefully considered in the hazard analysis. While the EG Food Company groups the omelets in the same hazard analysis, other companies may wish to address the cheese omelet biscuit in a separate plan because of the wheat allergen in the biscuit and the extra assembly step. The food safety team must organize the information in a meaningful way to communicate the significant risks to the staff at the facility. For reasons discussed previously, the hazard analysis and food safety plan will likely be different for the same product produced in different facilities. The food safety team must take into account the unique characteristics, equipment, and procedures used at their establishment when preparing the food safety plan specific for their firm. However, it is perfectly reasonable for the team to refer to generic HACCP or preventive control models, hazards and control guides, and decision trees to help them with their deliberations. Generic food safety plans, however, will rarely consider all of the specific aspects in an actual facility, thus they are for teaching or guidance purposes only. Sources of generic HACCP plans, which could serve as a starting point for a food safety plan, and resources are listed in additional reading at the end of the chapter. Other hazard analysis models and decision trees may be available from other reputable sources. As a word of caution, these resources may not consider hazards associated with sanitation, allergens, and supply chain programs to the extent required for food safety plans under the Preventive Controls for Human Food Regulation. The hazard analysis process identifies those hazards requiring a preventive control because they are known or reasonably likely to cause illness or injury in the absence of a preventive control. The preventive controls needed to manage these hazards may be specific controls in the process and, frequently managed as CCPs. They may be specific sanitation preventive controls to manage environmental pathogens or allergen cross-contact. Allergen preventive controls may also include production run sequencing and product labeling, which is discussed in Chapter 10, Food Allergen Preventive Controls. Some hazards requiring a preventive control need supply chain programs to verify control of the hazard by the supplier. Finally, the need for other preventive controls may be identified through hazard analysis, such as temperature control during transportation. The hazards requiring a preventive control in the e.g. food company example are summarized below. In the hypothetical omelet example, two process preventive controls were identified: cooking the omelet to inactivate vegetative pathogens and metal detection to prevent metal contamination of the product. The example illustrates three allergen preventive controls identified. 1. Ensuring that labels received from the printer accurately declare the allergens in the product. 2. Controlling the potential for allergen cross-contact at the assemble, wrap step, and 3. Ensuring that the correct product labeling with relevant allergens is put on the product. Some companies may consider the labeling step as a process control if, for example, they use a barcode scanner to monitor proper label application or manually compare a label and formulation each time new labels are added to the line. This is up to the specific operation. Some companies may have only one preventive control for allergen labeling when the label is placed on the package. Others may use two. 1. To check for errors on incoming batches of labels by an individual knowledgeable in label requirements, and 2. To check that the correct label is placed on the product. Each facility determines the best approach for their situation. 2 sanitation preventive controls were identified. 1. Prevent the potential introduction of environmental pathogens at the assemble, wrap step, and 2. Prevent allergen cross-contact at the same step. Sanitation of the assemble, wrap table would be the appropriate procedure to prevent allergen cross-contact. Hygienic zoning and sanitation procedures in the assemble, wrap environment would likely include more than just cleaning and sanitizing the assembly table. This is discussed in more detail in Chapter 11, Sanitation Preventive Controls. In the hypothetical omelet example, one preventive control for their supply chain program was identified, i.e., for the pasteurized processed cheese used in the omelets. E.g. Food Company does not have any process that would control the identified hazards, thus they rely on the supplier to control the pasteurization process to destroy vegetative pathogens and formulation to control C. botulinum. They manage this through their supply chain program by requiring a third-party audit. The details on how they obtain information from a third-party audit are discussed in Chapter 12, Supply Chain Program. Together, process, allergen, sanitation, and other preventive controls, including supply chain programs, greatly minimize the potential for the e.g. Food Company omelets to cause an illness or injury for the consuming public. Hazards are biological, chemical, or physical agents that have the potential to cause illness or injury. The hazard analysis process identifies known or foreseeable hazards that are known to be or have the potential to be associated with the facility or food it makes. These potential hazards are then evaluated to assess likelihood and severity to determine, based on risk, those hazards that require a preventive control. Through this process, an effective hazard analysis reduces risk and focuses implementation efforts on the preventive controls and associated procedures that are the most important controls for food safety. A poorly executed hazard analysis may overlook hazards requiring a preventive control, or may identify too many controls that really are less important for safety, thus making the food safety plan unmanageable. A written hazard analysis is required regardless of the outcome. Engaging technical experts may be useful for the hazard analysis to ensure that the hazards requiring a preventive control and appropriate preventive controls are identified. Let's take a look at some important definitions. Keep these in mind as you work through your hazard analysis. Known or reasonably foreseeable hazard. A biological, chemical, including radiological, or physical hazard that is known to be, or has the potential to be, associated with the facility or the food. Hazard requiring a preventive control. A known or reasonably foreseeable hazard for which a person knowledgeable about the safe manufacturing, processing, packing, or holding of food would, based on the outcome of a hazard analysis, which includes an assessment of the severity of the illness or injury if the hazard were to occur and the probability that the hazard will occur in the absence of preventive controls, establish one or more preventive controls to significantly minimize or prevent the hazard in a food and components to manage those controls, such as monitoring, corrections or corrective actions, verification, and records, as appropriate to the food, the facility, and the nature of the preventive control and its role in the facility's food safety system. Preventive control. Those risk-based, reasonably appropriate procedures, practices, and processes that a person knowledgeable about the safe manufacturing, processing, packing, or holding of food would employ to significantly minimize or prevent the hazards identified under the hazard analysis that are consistent with the current scientific understanding of safe food manufacturing, processing, packaging, or holding at the time of the analysis. Great job! You did it! Make sure you review all the chapter resources. Please complete all activities and exercises. See you in Chapter 9.